calcium hydroxide has a KSP of 6.5 times 10 to the negative 6. And the question is, find the molar solubility of calcium hydroxide. Calcium hydroxide has a KSP of 6.5 times 10 to the negative 6. The question is to find the molar solubility of calcium hydroxide. And remember that we can still use the same three-step method.
I think I kind of have a rough idea. Plus x and 2 plus 2x. And then cube equals 2 k. Is this a
Okay, yeah, you're doing good.
so, and it's going to be x, which is going to be 2x, 6.
Okay, let me interrupt you for a second, but that actually is really good. You really worked that out.
Oh, I mean squared.
That's even better. Okay, but let me interrupt you for a second. Although you're doing good, I think you're about to get the right answer. But let's just be a little bit more systematic. You wrote the equation of the ice. Now we have to saturate the solution, right? And how do we do that? We do that by adding an amount of salt that is equal to the solubility.
Mm-hmm.
But in this case, we don't know what the solubility is, because that's what the question is, right? So how much calcium hydroxide should we initially add? What should I write down for the initial amount of calcium hydroxide that we've added?
Question mark?
Maybe question mark, but to be consistent with what you did, well, how do mathematicians write a question mark? They write it as a variable. So the only mistake that you made is you started with the change row. I think that's the same thing we did in the last problem, right? That didn't really mess you up. I think you were going to get the right answer. But it's better to start with the start row. It's better to start with the start row. So how much of the calcium hydroxide do we initially need to add? Well, we don't know how much we need to add. So we're going to call that x. So what are we using x to stand for in this problem? What does x stand for?
It's how much we need to add.
Which is, yeah.
In order to like.
Right. And what's the name for that? How much do we need to add?
Salt.
Yeah. What's the name for that? How much
molars.
do we? It's the molar solubility.
Solubility.
So in this case, x. So let me write this down. X stands for the molar solubility of this substance. We need to add an amount that's equal to the molar solubility because that's what it takes to saturate the solution. So you always want to keep track of what your variables stand for. This is the molar solubility. We're adding the amount that it takes to saturate the solution. What should this starting amount be?
0, 0.
All right. And how much of this is going to get used up?
Minus x.
Because we've added something that will just saturate the solution. As we saw from that earlier table, there won't be any precipitate here. And this change will be?
Plus x and plus 2x.
And it's very good that you saw that this is plus 2x because of this coefficient. Yeah, this should be twice as big as this. So the ending amounts are?
0 and x and plus 2x.
Yeah.
I mean, it's 2x. So, and
Good.
it's more.
Then we would write Q equals KSP. And the Q here is calcium 2 plus times hydroxide. And I think you remember to square this.
And it's going to be.
We know the KSP was given to us.
It's going to be 4x cubed.
Maybe I would write it like this, Q equals K, but the K here is the KSP. So we would have X times 2x squared, and now I can write the KSP, 6.5 times 10 to the negative 6.
I know if we'll do square root is going to be, this was going to be 1, I think, how do we do that? X equals, you know what I mean, it's a special way to get rid of the, it's going to be like kind of square root, but then,
Cube root.
yeah, I think, no, it's here, okay, got it, remember now. So, in then, I don't know.
Okay, and now we have to know how to do this on the calculator,
Mhm.
right? Okay, there's a couple different ways to do this. Let's see.
But if it's not on the calculator, because like, I mean, we won't be able to use these ones. So can we do somehow? Like,
Sure. Okay, so how can you do this? So you'll have a calculator, but not a calculator that's as good as this,
no,
right?
Just
Okay, so here's the trick. The y root of x is x to the 1 over y power. You can always change a root into an exponent.
Oh.
You can always change a root into an exponent, and your calculator will have an exponent key. So even if it's not as good as this calculator, so you can still take this exponent.
Okay.
So, but because this is a 1 over, you have to put the exponent in parentheses.
So it's going to be then x equals 1.625 e to the minus 6 and to the 1 over 3. Okay.
So this would be the way to do that. This will work best if you use the E key for scientific notation on your calculator.
Mm-hmm. Enter, and it's going to be answer.
Yep, that'll work. Good.
And, no, it's going to be.
Yeah, you have to hit the caret for the exponents. Good.
X equals 0.0178118.
So I think we can round that to 0.012.
Mm-hmm.
What are the units on that?
Oh, it's going to be molars.
Right.
0.12 molars, and then we just plug this into the equation. The calcium 2 plus will be 0.12, and this just multiplied. It's going to be.
What's the answer to the question?
Oh, okay. It is 0 for this one.
What's the answer to the question?
Find the molar solubility of CaOH 0 molars.
That's the question. What's the answer to the question? Okay, that's right. I just wanted to make sure that was clear to you. Okay, that's right. So how do I know? Well, the question was asked.
Oh, because we have 1 calcium and we have 1 the coefficient of. We have 1 calcium ion 2 plus per. We produce 1 calcium ion 2 plus from 1 calcium OH.
That's true.
So
Yes.
That's
right. Okay, but there's an even simpler way to see that. What's the simpler way to see that? What did we decide that X was going to stand for in this problem?
0.012.
Well, yeah, but what did we decide at the start that X was going to stand for? What did we decide that X was going to stand for? What was the name of the concept that X was standing for?
Molar solubility of
Yeah. So we don't have to do any thinking to see that this is the answer, because we figured out that X equals 0.012. But we said that X is the molar solubility. So we don't have to think about it to see that this is the answer to the question. We decided to use X to stand for the molar solubility. So this must be the answer. X is the molar solubility. So the molar solubility of this salt is 0.012 molar. Okay. So it's not necessary in this case to actually calculate what these ending concentrations of ions are, because the question didn't ask us for that, although we could figure that out. What we really need is to know this, but this is just X. Well, that's 0.012.